Alright, this is the final version of the MTAP machine. I'm going to show you what we got here. It has its own dedicated faceplate. Notice there's a bunch of extra holes. Those are 1/4 tap holes, because eventually this machine is going to be fully automated, where all your bullet pointing MTAP process is done automatically. But for now, we're going to release the manual version, and later it can be upgraded. That's what all those mounting holes are. So let's talk about what we got here. We've got the bullet guide system, which this is a precision 1/2 thousandths clearance onto the actual bullet itself. Okay, you've got the chip box. You unscrew here. All the copper shavings come down through that passage into this little catch, so they don't build up inside and it doesn't make a mess. If you want to leave that off and just let the copper chips sling everywhere, that's fine too. We've got the depth of cut checker. See, we've countersunk stainless hardware, dowel pinned. This machine is made to mount that way, or you can store it and or use it vertically. There's going to be a through hole where the chips basically will come out the bottom. In this instance, we'll probably make some sort of catch pan there to catch the chips. So this is a whole dedicated machine. If you notice, this whole precision spindle bearing system is the exact as the IDOT and AutoDOT. All your precision is done here. So clamp this here. A lot of you may be thinking, you know, what's involved here? This is a much more precision machine than, say, the Girard trimmer. That's a stamped steel construction that doesn't datum anything off of the back of the bullet, and it doesn't precision guide anything. So these bearings, you can see they're this big around, you know, basically 2 3/4 inches, where the ones like on the Girard, you know, they're half that size. This is a much more precision, much heavier duty machine. The distance between the two bearings determines the stability. You can see that distance there is a great distance. Uses the same 5C collet as the standard IDOT and AutoDOT does. The cutter head is inside, so you're fully protected. So your fingers, you know, nothing gets cut. You can position the indicator, the depth of cut checker, anywhere you want. It's just on a set screw. It's got a non-marring pad here, so you don't scratch your base plate up. So yeah, that's what the system is. So everybody's been asking about pricing. Well, unfortunately, it's higher than I wanted it to be. The problem is cost of materials, labor, parts, components, bearings. You know, these are Japanese bearings. These aren't cheap bearings in here. I'm going to show you here. See that? That's Japanese bearings. Best bearings you can get. So everything is, to have precision, unfortunately it just costs. This machine is going to retail for about $1,200, and a lot of people may say, whoa, why so expensive? Well, we tried everything we can to get that cost down, and to have it where it was still user friendly and have the same precision that we need. Unfortunately, after months and months of development, this fit all those bills, and our cost on everything here is close to $1,000. So I'm not making much on these. That's unfortunately just what it costs. I wish I could sell it for $750 and it only cost me $300 build, but unfortunately that's just not the case, and that's not going to happen. So that's where the price point is going to be. That's going to include one cutter head that has the 3 cutters in it. That's going to include one bullet guide system, so like for 7mm, and then that's going to come with the bullet holder. Let's talk a little bit about the bullet holder. How does this work? Well, we got it to where there is a 1/4/80 super fine pitch set screw with 2 lock screws. Those are nylon. You actually don't even have to loosen or tighten those. It just provides the friction for that. And that screw, and has a precision ball bearing on the back to datum. That goes in and out so you can adjust your depth of cut. This red button here, that is to push, and it keeps the bullet from spinning. All right, and you let it go, bullet comes out. Okay, so you push that there, hold that down, doesn't mar the bullet. It goes up, pushes up against this precision surface, keeps things straight. Oops, and then when you're done, you just release it. So let's show you how it works. So push that there. See there? See that tip? So anyways, yep, so it just goes in there. You just grab the bullet. Let's set this up here. Those numbers, but so I just set this up, so we're gonna 0 that. So now we have a datum. We've done testing, 1,000 yards, and if you're within 2,000ths, it makes no measurable difference. So don't try to fight it like the last, half a thou. But as you can see here, like that, that's 3 zeros and half a thousandths. Very good. So as you can see here, I'm just pulling bullets out of the box. No sorting prior. That goes there, pull that out. If you can see that tip, I mean everything's nice and uniform. 1/1000. So if you think about the time that you would normally spend, right? So let's say you sort by overall length. You're measuring these and then you're sorting. But what are you really sorting by with overall length? I mean, look at this MTAP. See if I can get it to focus here. But what are you measuring? The jagged highest point? Okay, what about the lowest point? Measuring overall length, I mean, yeah, that kind of gets you sorted by BC because it's really where the air starts getting interrupted and where it connects back to each other. But I mean, as you can see here, there's nothing consistent about that. So then you say, okay, I sort by overall length, and then I point them. Okay, so then you sort them by overall length, and then you run them in a pointing die. So now this portion of the bullet is going to swedge more in point than this portion, and then it's going to try to push it off center line. So where's your consistency? Okay, so then you trim based on ogive, right? Because like in a Gerard trimmer, you're stopping there, but then you're sorting by overall length, and then you have a 10,000ths window, and then you're pointing off of that. So then you have all these groups, and then you're swedge pointing where you have the chance of distorting the jacket. But with the MTAP system, everything's datomed off the back of the bullet, which is where BC consistency comes from, right? So now you have a point that, and you can see we've about closed up that knee flat hole. Look at that, 1/1000. So now if you think about how long it takes to do this, there's no system. I bumped that indicator, so we're going to grab the last bullet I did. So I bumped that with my hand. We're going to recalibrate it. Oh, that's good. There we go. There, within 1/2 thou. Oh, you guys can see that or not. So, see there? Bullet spins. Lock it down with the lock. Just with your thumb pressure. You push in. And I encourage guys to test different depths of cut. You really can't go too far and hurt the bullet. I mean, you can, but not within reason. So see that 0.000, right on the money. I mean, you can see we've turned the machine on and off, talked about it, different bullets. You can see the consistency. I mean, it's just spot on, right? So if you think about the cost, right? How much are we paying for an amp and annealer? We're paying, I don't know what they are, $12.50, maybe more than that now. Okay, that literally can be replaced if you want to get down to it by a simple $50 induction coil and a controller. You're really just paying for software or development. For here, the problem is the cost is so many precision materials, precision machining. This is Mike 6 tooling plate, blanchard ground, flatness within, you know, I think it's about 5,000 every square foot as a maximum. Everything CNC machined, heavy duty, you know, rubberized feet, anti, you know, or dampening feet. There's just a lot that goes into it. So if you think it's too expensive, don't buy it. I mean, I've done the best I can. If it doesn't fit your budget, then continue doing your bullets the other way. But I will tell you this, we've sent these bullets around to guys all over the country, top shooters, and every single one of them has come back and says, I need a machine and I need a machine now. So I think the proof is there. Like look at this bullet. Look at that, how jagged that is. I mean, take that here, process that. It doesn't really matter how long it is to start with, it's going to be the same length when we're done. Now look at that bullet tip. And you can say, why we like to indicate is, you can see there, that's 3. That means I didn't get it pushed all the way in. Okay, so we can put that back in. Double check that we have that cut the same. You can see there, 0.0005, half a thousandths. You can see where this is datuming on. It's the depth of that cut relative to the back of the bullet, which is how it should be in my opinion. This is a 1/8 horsepower motor. This is, you know, this is an expensive motor. This is a big expense of the part, but it's air cooled. Everything is super precision on this. You can kind of see the size here. We made the plate where it's just about the same size as the motor assembly. So yeah, that's where we're at with this. We're gonna have them up on the website this week. Like I said, think it's too expensive, continue doing what you're doing. We did the best we can, and that's what it is.